Let's be real. We're all swimming in a sea of information, right? Well, today, we're going to unlock a powerful toolbox that can help us navigate it. We're going to dive into what science really is and, more importantly, how you can use its tools to make sense of the world all around you. So, let's get into it.
This is the million-dollar question, isn't it? We get flooded with headlines and claims every single day. So how on earth do you figure out what's real and what's not? The answer, it turns out, lies in a process, a mindset. It's a powerful method for sorting out the facts from the fiction. And that, right there, is the heart of science. So let's go ahead and open up this toolbox. When we talk about science, we're not just talking about some giant, dusty textbook filled with facts. Nope. We're talking about a method, a process, really a whole way of thinking.
Okay, the magic phrase here is systematic method. Science isn't about making random guesses or going with what feels true. It's a really structured way of doing things. You observe, you experiment, you analyze, all to build a solid, reliable understanding of how our world works, from the tiniest atom all the way up to the biggest galaxy. Think about it. Any good toolbox has tools you can really count on. In science, that trust comes from this amazing built-in quality control system. You can almost picture it as a checklist that every single scientific idea has to get through before it's taken seriously. And this checklist, this is the core of what makes science so strong. First, ideas have to be based on empirical evidence, actual real-world proof. They have to be testable. And here's a big one. They have to be falsifiable. That just means there has to be a way to prove the idea wrong. So if I claim all swans are white, all you need is to find one black swan and boom, my claim is toast. On top of that, the results have to be reproducible by other people, the process has to be objective, and it should fit with what we already know. This whole system is what separates science from plain old guesswork. But wait, there's one more hurdle. The ultimate final check, peer review. Before a study gets published, it's sent out to other experts in that exact same field. And these folks, they act like detectives, scrutinizing the work for any errors, biases, or flaws. It's a really tough process to get through, but it's absolutely essential for making sure only the highest quality, most reliable work sees the light of day. Okay, so that's the process, this incredibly rigorous system for finding knowledge we can trust. But so what? Why does this toolbox even matter? Well, let's take a look at what we can actually build with it. For starters, just look around you. The smartphone you might be holding right now, the electricity powering your home, the medicines that keep us healthy, every single one of those things is a direct result of scientific discovery. And it goes way beyond just gadgets. Science gives us the tools and the knowledge to take on massive, global-scale challenges. Everything from developing clean energy to fight climate change to creating vaccines to stop pandemics in their tracks. And on a really personal level, scientific research leads to incredible breakthroughs in medicine and public health. It's the reason we have antibiotics, CAT scans, and a much, much deeper understanding of how we can live longer, healthier lives. But maybe the most powerful thing science builds isn't something you can hold in your hand at all. It's a way of thinking. It literally trains our brains to look at evidence, to question our own assumptions, and to make smarter decisions, whether we're in a lab, at the grocery store, or just scrolling through social media. Now, we all have this stereotype of a scientist in our heads, right? Someone in a white lab coat, maybe with crazy hair, surrounded by bubbling test tubes. But the reality, it's so much bigger, so much more inclusive than that. So who actually gets to use these tools? The scientific community is huge. Sure, it includes university researchers, but it's also the engineers building our cities, the doctors and nurses healing us, and the teachers who are inspiring that next generation. And get this, it even includes citizen scientists. That's people just like you who contribute to real research by, say, tracking bird migrations or collecting water samples. The big takeaway here is that science is for everybody. All right, so to really use this toolbox well, we need to speak the language. We need to understand the blueprints for scientific ideas. There are a few keywords that get thrown around and misused all the time, so let's clear them up right now. First up, the most basic building block, a fact. A fact is simply an observation that's been confirmed over and over again. For example, it's a fact that water boils at 100 degrees Celsius at sea level. You can check it. It's verifiable. Simple as that. Next, we've got a hypothesis. Now, this isn't just some random guess. It's a specific, testable prediction. Something like, if I give this plant more sunlight, then it will grow taller. See, it sets up a clear starting point for an experiment. And that brings us to maybe the single most misunderstood word in all of science: theory. In everyday conversation, we say, "Oh, I have a theory," when we mean we have a hunch or a guess. In science, it's the complete opposite. A scientific theory, like the theory of gravity or the theory of evolution, is a massive, well-supported explanation for how some part of the world works. It's basically the ultimate achievement in science. So let's put them side by side to make it super clear. A hypothesis is a focused prediction for one experiment. A theory is the huge, overarching explanation that ties together tons of facts, tons of hypotheses, and a mountain of evidence. Think of a hypothesis as one brick, and a theory as the entire solid building made from thousands of those bricks. And finally, we have a scientific law. A law, like Newton's law of universal gravitation, describes a pattern we see in nature. It tells you what will happen, like that apple will fall from the tree. But it doesn't explain the deep mechanism of why. The why part, that's the job of a theory. So when you put it all together, the process, the people, the language, you end up with this really powerful idea. Science isn't just another subject in school, it's the engine that literally moves humanity forward, helps us solve our biggest problems, and genuinely improves our lives. So, we've unpacked the toolbox, the principles of scientific thinking, being curious, demanding evidence, thinking critically. They're all yours to use now. The only question left is, what will you discover? Thanks for joining this explainer.